Hello, future toppers. Let's make maths simple, intuitive, and fun together. So, we got wholesome new problem in which we have to find area bounded between y equals cos inverse x and y axis. Between y equals to this and this. So, first we will be focused on graph tracing and then we will proceed. Okay, so first try to draw the graph of cos inverse function. So look at this how it will go. Okay, so you know that the graph of cos inverse x function is above x-axis only and it goes this way. So this is what? This is 1, this is -1, this is pi by 2 and this is pi. Okay, so this is the graph of cos inverse x. Now y-axis is there and then you have to plot y equals to pi by 2. So y equals to pi by 2 is this. Look at this, your y equals to pi by 2. Done. And then we have y equals to pi. So this is y equals to pi. So technically you have to find out this area. Okay, I hope you understood the question that we have to be focused on which part. Okay, so I feel that for this specific question we should go with dy. Okay, so for that we will take small strip of dy and then we will proceed. So here we have y equals cos inverse x. Now look at the area. So area is integration from pi by 2 to pi and then dy. So if this is dy, we have to write x. If we will write dx, we will write y. So who is x? X is cos y. So integration from pi by 2 to pi cos y dy. Now I hope you remember the integration of cos y. It is sin y. Correct? Sin y plus constant c. So no need to write down the constant part because you are handling definite integration which will neutralize that part. So this is pi, this is pi by 2. Now substitute the upper limit. So sin pi, you know that sin pi is nothing but 0 minus sin pi by 2. Sin pi by 2 is 1. Okay, so we got area as -1. You also know that you cannot have negative area. Okay, so what we will do? We will put mod on it so that we can have the positive area. So at the end, what you have to do? You have to take modulus. Okay, so it is 1 square unit. I hope the idea is clear and you got the concept. So see you guys in next session of MathFlix.